Hey guys, welcome to my YouTube channel. In this video, I'm going to show you how to calculate the following soil properties: void ratio, moisture content, degree of saturation, porosity, bark density, and dry density. The question is, a sample of soil has a wet weight of 0.7 kg and the volume was found to be 0.00035 cubic meters. After drying out, the weight was reduced to 0.6 kg. The particle-specific gravity test gave 2.6. Determine the following. Without further ado, let's go straight to question A and find the void ratio. Void ratio can be defined as a ratio of space occupied by the void. Mathematically, it is given as E equals VV over Vx, where Vx stands for volume of solid and VV stands for volume of void. So let's go back to the equation. So we want to find the void ratio, but we are not given the values for VV and Vx in the equation. We are only given the values for the weight of the wet soil, which is 0.7 kg, the total volume of the soil sample, which is 0.00035 cubic meters, the weight of the dry soil, which is 0.6 kg, and the particle-specific gravity, which is 2.6. So how are we going to find the void ratio? In order to find the void ratio, first we're going to find the value for Vx by using the following formula. So this is the formula for the density of solids. In this formula, rho x stands for density of solids, mx stands for mass of the dry sample or weight of the dry soil, and then Vx stands for volume of solids, Gx stands for value of the specific gravity test, which is given as 2.6. Lastly, rho W stands for density of water, which is known to be 1000 kg per cubic meters. Of course, it is not given in the equation, but it is known to be 1000 kg per cubic meters. So you have to know this by heart. So what we want to do is to make Vx the subject of formula. So in order to make Vx the subject of formula, we're going to use the right-hand side of the equation, then rearrange it by cross-multiplying. Now let's make Vx the subject formula. We have mx over gx rho w. So let's go back to the equation. From the equation, we have the following values given to us. W subscript W stands for the volume of the wet soil. W subscript D stands for the weight of the dry soil. It is also denoted by mx, which is the mass of the dry sample. Throughout this video, I'm going to use these symbols interchangeably to represent the mass of the dry sample. And also in some textbook, W subscript X is used to represent the mass of the dry soil or weight of the dry soil. So just take note of that. V stands for total volume of the soil sample, and Gx stands for the value of the specific gravity. Plug in the values into the formula. Vs equals mx, which is the mass of the dry sample, 0.6 kilogram over 2.6 times 1000, which is the density of water. So 2.6 times 1000 is 2600 cubic meters. So we have 0.00023076992. So let's approximate this to three significant figures. We have 0.000231 cubic meters. So this is the volume of solid. So now that we have calculated the volume of solid as 0.000231 cubic meters, let's calculate the volume of void in order to get the void ratio. So the formula for the volume of void is volume of solid subtract from the total volume will give us the volume of void. So the total volume from the equation is given as 0.00035 cubic meters. So if we plug in the values, we have 0.00035 cubic meters minus 0.000231 cubic meters. So the answer is 0.000119 cubic meters. So now we have the value for the volume of void and the volume of solids. Let's plug in the value into the formula for void ratio and calculate the void ratio. Then divided using our calculator, we have 0.515 as the void ratio. So this is the void ratio. Next, let's calculate the moisture content. Moisture content can be defined as a quantity of water contained in a soil expressed in percentage. Mathematically, it is given as MW over mx, where MW stands for the mass of water, the M stands for mass of the dry sample. So in order to calculate the mass of the water, we are going to subtract the weight of the dry sample from the weight of the wet soil. So from the equation, the weight of the wet soil is 0.7 kilogram. The weight of the dry sample is 0.6 kilogram. So if we plug in the values into the formula, .7 kilogram minus 0.6 kilogram over 0.6 kilogram. 0.7 kilogram minus 0.6 kilogram equals 0.1 kilogram divided by 0.6 kilogram. So the answer is 0.167 kilogram. Since moisture content is usually expressed in percentage, let's multiply 0.16 kilogram by 100. So we have 16.7 percentage as the moisture content. So this means that 16.7% of the soil sample contain water. So alternatively, we can also use this formula to calculate the moisture content instead of the other one. Here, M stands for moisture content, VW stands for volume of water, V stands for volume of solids, and G stands for specific gravity of the soil particle. As you can see, we have the value for the Vx, volume of solids, and the specific gravity, but we don't know the value for volume of water. So I'm going to show you how to find the volume of water in the next calculation. So next calculation is the degree of saturation. Degree of saturation can be defined as a percentage of void space which is filled with water. Mathematically, it is given as x subscript r equals VW over VV. VW stands for volume of water. Now, in order to find the volume of water, we are going to use this formula. M W over rho W. So the M W stands for mass of water, while rho W stands for density of water. The reason why we use this formula is because, if you remember in physics, the density of a body is given as. So if you know the values for the density and mass of a body, you can find the volume of that body. All you have to do is just to make V, which is the volume, the subject of formula. So if we make this the subject of formula, we have so as you can see, it's the same thing. So except that we are looking for the volume of water. So in order to get the volume of water, we are going to divide the mass of the water by the density of water. MW can be calculated by subtracting the weight of the dry soil from the weight of the wet soil. So if we subtract it, which is 0.7 kilogram, weight of the wet soil minus weight of the dry soil, 0.6 kilogram, divided by density of water, we have 0.1 over 1,000. So the volume of water is 0.0001 cubic meters. So now that we have the value for the volume of water, we are going to plug it into the formula in order to get the degree of saturation. So the volume of water from our calculation is 0.0001 cubic meters, and the volume of void from our previous calculation, we got 0.000119 cubic meters. So if you plug in values and then divide it, we have 0.840336. Let's approximate it to significant figures. We can also express it in percentage by multiplying it by 100. So if you multiply it, we're going to get 84% as the degree of saturation. Alternatively, we can also use this formula to calculate the degree of saturation, where M stands for moisture content, J stands for specific gravity, and E stands for void ratio. So if you have all these values for these parameters in the formula, we can find the degree of saturation, and we will get the same answer similar to the one we got from this formula. So if we plug in the values into the formula, the moisture content from our previous calculation is 0.167 times the specific gravity from the equation is 2.6. The void ratio from our previous calculation is 0.515. So if you do this calculation, you're going to get 0.84 as the degree of saturation, which is the same thing as this one for this formula. So next, we are going to calculate the porosity. Porosity can be defined as the amount of pore or open spaces in a soil. Mathematically, it is given as VV over V. VV from our previous calculation is 0.000119 cubic meters, and the total volume of the soil sample is given as 0.00035 cubic meters. So if we plug in the values, then do the calculation, we have 0.34 as the porosity. Alternatively, we can also use this formula. So if you know the value for the void ratio, we can find the porosity by using this formula. From our previous calculation, we got the void ratio as 0.515. So 1 plus 0.515. If we add it up and divide 0.515 by 1.515, you're going to get similar answer with this one, which is 0.34. Next, we're going to find the bulk density. The bulk density can be defined as the mass of the natural soil without the moisture content per unit volume. Mathematically, it is given as rho equals m over v. This is the formula for density of a body. Here, m stands for the weight of the wet soil or weight of the wet sample, and then v stands for the total volume of the soil sample. So if we plug in the values, we have 0.7 kilogram divided by the total volume, which is 0.00035 cubic meters. We have 2,000 kilogram per cubic meters as the bulk density of the soil. Next is a dry density. So the dry density can be defined as the density of the dry sample. So mathematically, it is given as mass over volume. So the difference between the dry density formula and the bulk density formula is that m stands for weight of the dry sample, not weight of the wet sample. From the equation, the weight of the dry sample is given as 0.6 kilogram. If we divide 0.6 kilogram by the total volume of the sample, we have 1,714 kilogram per cubic meters. So this is the dry density of the soil sample. This is the end of this video for how to calculate soil properties. So this is the formulas that we have used to calculate the soil properties in this video. So just to recap, the degree of saturation can be calculated using this formula or this formula. It just depends on the parameters that you are given. Also, the moisture content can be calculated using this formula or this formula. Porosity can be calculated using this formula or this formula. So this is the volume of soil. Now this is the water ratio formula. Then this is the dry density formula. And then lastly, this is the bulk density formula. Okay guys, thank you for watching my video. Please, if you enjoy my video, like and subscribe to my channel for more videos like this. Bye.